Starlink 11 to 16. May 23rd SpaceX launch from California marks new heights in orbital logistics, global internet expansion, and booster reusability. In the dawn hours of May 23, 2025, as sunlight crept over the Pacific horizon, a new chapter was written in the increasingly storied chronicle of 21st century spaceflight. From Space Launch Complex 4E, SLC-4E, at Vandenberg Space Force Base in California, SpaceX launched another Falcon 9 rocket carrying 27 Starlink satellites into low Earth orbit. Designated Starlink Group 11 to 16, this mission exemplified everything that the modern space age has come to represent. High frequency, high precision, high ambition. What might have once merited headlines and fanfare for being a relatively rare event, launching a rocket into space, has, thanks to SpaceX's remarkable cadence and engineering efficiency, become a near-weekly demonstration of industrialized spaceflight. Yet despite the frequency, the magnitude and implications of each mission remain profound, and this launch was no exception. The star of the show, yet again, was a well-traveled workhorse, Falcon 9 first stage booster B-1075. Performing its 18th flight, B-1075 has now become one of the most proven pieces of launch hardware in SpaceX's fleet. A fleet that has redefined what it means for a rocket to be reusable. This particular booster has now carried payloads into orbit on 14 previous Starlink missions, the Transporter, 11 rideshare flight, and Sarah 2, a German military reconnaissance satellite. Originally designed for 10 flights with light refurbishment, Falcon 9 boosters like B-1075 have vastly outpaced even SpaceX's own expectations. With each successful recovery and reflown mission, the economic and technological benefits of reuse are not only reaffirmed, they are recalibrated. The implications stretch across national economies, defense infrastructures, and global communications. Following a picture-perfect countdown and nominal liftoff, the Falcon 9 thundered into the sky, piercing through the low-altitude marine layers that often roll in along California's coast. Just over 2 minutes after launch, the first and second stages separated in a clean sequence. As the second stage continued its ascent to deliver the payload to its planned orbital shell, the first stage initiated a carefully choreographed series of engine burns, boost back, re-entry, and landing. Guiding itself through atmospheric drag and gravity losses, B-1075 deployed its titanium grid fins, made real-time corrections with cold gas thrusters, and lit its center Merlin engine one final time. The booster descended toward the waiting autonomous drone ship of course, I Still Love You, stationed several hundred kilometers off the coast in the Pacific. Despite unpredictable sea swells and shifting wind patterns, the Falcon 9 stage landed vertically with near-centimeter precision, a ballet of ballistic mathematics and robotic agility. The recovery marked the 450th successful booster landing for SpaceX, a figure that still seems surreal when one remembers that just a decade ago, no company or agency had ever recovered an orbital-class booster. The milestone is more than symbolic. It signals the culmination of a tectonic shift in how humanity accesses space. Traditional expendable rockets, costing $60 million to $150 million per launch, are no longer economically viable for high-cadence operations. SpaceX's reusable architecture slashes that cost by 60 to 80%, allowing for unprecedented scalability. It is the difference between 1 or 2 national missions per year and the possibility of launching thousands of satellites annually to build out commercial, scientific, and even planetary-scale infrastructure. The 27 Starlink satellites launched during this mission are not just technological payloads. They are the literal building blocks of a digital future. Each spacecraft, weighing around 300 kilograms, was equipped with inter-satellite laser links, phased array antennas, and autonomous navigation software. These satellites are designed to mesh together in orbit to form a self-healing, low-latency network capable of delivering internet access to virtually any point on Earth. Operating in low Earth orbit at altitudes of approximately 550 kilometers, Starlink satellites circumvent many of the latency problems that plague traditional geostationary systems. More importantly, they require no terrestrial infrastructure beyond a small user terminal, a vital advantage in rural or disaster-stricken areas where laying fiber or building cellular towers is not feasible. With over 8,700 satellites launched and more than 7,500 still operational, Starlink is no longer a proof of concept. It is an operational behemoth. The system is currently serving over 3.5 million customers in 70-plus countries, including isolated villages in the Andes, shipping vessels in the Atlantic, research stations in Antarctica, and mobile hospitals in war-torn regions of Eastern Europe. In Ukraine, Starlink terminals became indispensable tools for military communication and civilian internet access alike, following the disruption of traditional communication infrastructure during the early stages of Russia's invasion. These real-world applications illustrate why the expansion of the Starlink network is not merely about consumer convenience, but about sovereignty, resilience, and democratized information access. The decision to launch from Vandenberg was, in itself, strategic. The California facility provides a clear corridor for polar and sun-synchronous orbits, ideal for covering latitudes that geostationary satellites struggle to reach efficiently. Polar launches are essential for ensuring global coverage, especially for real-time services in the polar regions, which have long been underserved. The site's rugged coastal geography and proximity to uninhabited ocean corridors make it ideal for downrange flight paths with minimal risk to populated areas. In a world increasingly dependent on real-time data, Earth observation, and communication bandwidth, polar orbit capacity is no longer optional. It is critical. In parallel with the Starlink constellation, SpaceX's infrastructure for launch, landing, and refurbishment has become a marvel of modern aerospace logistics. The drone ship used in this recovery, Of Course I Still Love You, is one of 3 such platforms in the company's ocean recovery fleet. Equipped with station-keeping thrusters, autonomous navigation systems, high-definition tracking cameras, and remote-operated fire suppression tools, OCSLI is the final node in a system that allows Falcon 9 boosters to reach orbits that would be impossible if they had to return to land. It is a floating extension of SpaceX's launch facilities, a ship that turns open ocean into reusable infrastructure. This entire mission, from ground prep to orbital deployment to marine recovery, reflects an astonishing degree of systematization. At any given time, SpaceX is coordinating dozens of parallel operations, refueling boosters, integrating payloads, preparing drone ships, reviewing telemetry from prior missions, upgrading Starlink ground stations, and writing software updates to be uploaded to orbiting satellites. Few organizations, public or private, can match this level of vertical integration. And it is this internal control, this fusion of hardware, software, and logistics, that allows SpaceX to iterate faster, launch more frequently, and reduce cost with every mission. Looking forward, the implications of May 23's launch stretch beyond the terrestrial. Starlink is not just an end in itself. It is the proving ground for technologies that will eventually support lunar infrastructure, Mars colonization, and interplanetary logistics. Everything SpaceX learns from these Earth-based missions, how to manage high-throughput networks, how to automate satellite station keeping, how to manufacture and launch hardware at scale, is being poured into its next-generation systems. The fully reusable Starship, currently undergoing testing in Texas, and next-gen Starlink satellites that will be deployed aboard it. When Elon Musk speaks of creating a multiplanetary civilization, missions like Starlink 11 to 16 are the practical, daily building blocks of that distant vision. Thus, while the May 23rd launch may, at first glance, resemble another in a long line of similar missions, it is in fact a microcosm of something much larger. It is a moment in a transformation that spans continents, orbits, and futures. It is one more successful test of hardware, software, and human coordination, executed at the speed and scale necessary to connect every schoolchild, every medic, every refugee, every scientist, and every explorer to the same digital fabric. In doing so, it not only narrows the digital divide, but redefines what is possible in the 21st century and beyond. SpaceX's Starlink 11 to 16 mission, with its 27 satellites and 18-time flown booster, launched from a fog-kissed California pad and landed on a ship dancing with the ocean. But it also reached far beyond that moment, into homes and hospitals, into classrooms and conflict zones, and ultimately into history, as yet another act in the unfolding story of humanity's relationship with the stars.